Hello and welcome to the section 3.5 lecture today. I do apologize, I kind of lost my voice this weekend. A little bit too much yelling and not enough soothing liquids to make it a little bit better. So I'm going to do my best. You do your best. If you have any questions, please let me know. So dividing rational numbers is everything that we're talking about today, and it says on this first problem that a diver needs to descend to a depth of 100 feet below sea level, and she wants to do it in 5 equal descents. Now this is typically in diving because you have to kind of regulate your body, you have to regulate your body's internal pressure to the external pressure that you get when you go deeper and deeper. You kind of have to pop your ears. And there's some other things that you have to do as well. So in this problem, how far should she travel in each descent? To solve this problem, we can set up a division problem that says she wants to go down 100 feet in 5 equal descents. And then how far should she travel in each descent? So it says to rewrite the division problem as a multiplication problem. And we think about some number times 5 equals negative 100. So we are taking 5 here. 5 times what would give us negative 100. And then we do want to know that we do want to talk about the integer rules a little bit. For multiplication, we know that in order to get a negative over here, that one of my two factors have to be negative. And I know that 5 is positive because she's not taking a negative amount of descents, I guess is the best way to put that. So, excuse me. But since 100 is positive, well, maybe we say, 100 isn't positive. I guess we wanted 5 there. Since 5 is positive, we know that the other factor has to be negative. And if we know that 5 times 20 is 100, the rules for integer multiplication, the sign rules, say that should be 5 times negative 20 to give us negative 100, or that the diver should descend 20 feet in each descent. So it says, what do you notice about the quotient of two rational numbers with different signs? Just like this problem here, that different signs are going to give us a negative answer, or a negative quotient. Okay. What do you notice about the quotient of two rational numbers with the same sign? Does it matter if both signs are positive or if both are negative? Same signs, we have the opposite going on. We're going to have a positive quotient. And no, it doesn't matter if they're both positive or both negative. As long as they're the same, that's the key. Okay, and that's kind of the easy way to figure out multiplication and sign rules. Okay, as opposed to, you can always talk about the good thing happening to a good person, that whole conversation. Or you can just think if the signs are the same, it's positive. If the signs are different, it's negative. Okay, and I'm not going to write anything for the doesn't matter part. So this is just kind of a summary of this, and if you noticed, it doesn't really matter whether this says quotients or products. Multiplication and division work the same way when it comes to signs. Okay, so this is kind of an important thing at the bottom that they just kind of skim over for now, but negative P over Q, right, and that P over Q in parentheses, meaning do that first, is the same as a negative numerator and the same as a negative denominator. And so we're going to look at this for all these. It says find each quotient, then use the rules you found in Explore Activity 1 to make sure that the sign of the quotient is correct. So if I take 12 and divide it by negative 4, using our tips from exercise 1, sorry, I'm thinking negative 4 times what is going to give me positive 12. Well, so since the 12 is positive and the 4 is negative, I know that this other piece needs to be negative to sort of cancel out the negative and give a positive 12. And I'm thinking that's going to be negative 3. Okay. The second one says 4 times what gives me negative 12. Well, again, I need a negative and an answer, and I have a positive here, so this is going to have to be a negative. And then again, 4 times 12 is 3. Sorry, 4 times 3 is 12. This one's a little bit tougher to visualize for this. So let's just do the division. 12 divided by 4 is 3, and then make it negative. There we go. What do you notice about each quotient? They all equal 3. Well, I should say they all equal negative 3. The rational numbers are equivalent. They're all the same thing. Explain how the placement of the negative sign in a rational number affects the sign of the quotients. It doesn't affect it. It doesn't matter. This is what I wanted to say. It doesn't matter. Oh, jeez. Sorry. So I'm just going to say it doesn't matter where the negative is located. And we are talking about division problems. I have all these are written out as fractions, and I'm not a big fan of it written this way, but if it was a division problem, it could happen. It's actually much more likely, but as a fraction, that just looks weird. Okay. So they want us to write 2 equivalent fractions for each quotient. Use the ones that are up above. Okay, use the same idea as what's above these 3. So instead of negative 14 over negative 7, we could say negative 14 over 7, or we could say negative the whole thing, 14 over 7. For this one, we have 2 negatives, which actually is just going to be the same as positive 32 divided by 8. And then it's kind of tough to come up with another one, because, yeah, we could say that. That's probably what I would go with. Okay. So that's actually going to take us to our code word for the day. We've seen it enough today, and I'm going to just kind of sneak it in right here. We've probably even had it before, but that's okay. This is going to be our code word, the word quotient. Okay, the word quotient will be our code word for today. All right, let's go ahead and get along here. We're actually going to look at some a little more complex division that we'll see. But still, we do have a heavy focus on the signs. It says over 5 months, Carlos wrote 5 checks total for a total of $323.75 to pay for his cable TV service. his bill is the same each month, and then what was the change in Carlos's bank account each month to pay for cable. So the 323 is like a total over 5 months. And then that bill was the same every month, so we can divide it by 5 and see what we have to pay each month. So they go through and they determine the sign of the quotient. They say, let's look at negative divided by positive. So it's going to be a negative. And then they just do the division of, they don't show us how they do that division, but they do the division of 323.75 divided by 5. Okay. Now for dividing fractions, they don't have any fancy problem for us here. This is called a complex fraction when you have one fraction over another fraction. But if we think about fractions as just being division, this really just says 7 over 10 divided by negative 1 over 5. Okay, that's all it's saying. Now, when we do division of fractions, okay, we keep the first one, we switch to multiplication, and we flip the second one. Many people learn that as keep, switch, flip. I don't like. Some people keep, change, flip. I don't know what the big difference is, and I don't know who says what, but the technical term is to multiply by the reciprocal. So we're keeping the first one the same, and we're flipping the second one over, turning it into multiplication. So when we do that multiplication straight across, we can cross reduce if we want. I would say this is a 2, this is a 1, maybe a negative 1 to take care of that. 7 times negative 1 is negative 7. 2 times 1 is 2. There we go. Let's look at that. Well, we got a couple problems here. Division of fractions. It's not the best. Sorry, the division of decimals. It's not the best. Kind of my recommendation is to treat it like whole numbers, and then just however many decimals are in your question is how many decimals in your answer. Kind of like multiplication. But so I think like 28 divided by negative 4 is negative 7. And there's one decimal, so it's negative 0.7. Okay. We do have a complex fraction here. I'll go ahead and flip that over. So first one divided by second one. I can go ahead and think about my signs. They're both negative, so that would be the same as if they were both positive. So I'm going to switch it to positive and multiplication. Flip the second one. 7 times 5 is 35. 8 times 6 is 48. And I don't have anything that can cross reduce or anything like that. Okay. Negative 5.5 divided by 0.5. So I'm thinking about 55 divided by 5, which is 11. And I notice I have 2 decimal places here, so there will be 2 in my answer. Excuse me. And it is negative, so we get negative 2 decimal places. There we go. So that being said, that's it for today. Make sure you get the code word, you write it down somewhere, and if you have any questions, let me know. Otherwise, have a good day, and we'll see you in class.